Now that we've finished building our React project, Monsters Rolodex, we are actually going to start building our final project, which is a fully fleshed out e-commerce platform. We're going to expand upon all of the topics that we covered today doing this Monsters Rolodex, but we're also going to use more patterns and more of the fundamental libraries in the React ecosystem that large companies are already using to build their web applications today. So let's take a look at what we're actually going to build. This is our final e-commerce project. We're going to have navigation and routing that takes us to different pages of categories of items. And from these items, we're actually going to be able to add them to our cart. And from our cart, we're actually going to see these things directly update. And from this cart, we're going to be able to check out, increase or decrease these items again, and see the live changes in both our checkout page and our cart page, remove items, and actually integrate with a Stripe API so that we can handle payments. Now, this is actually going to be a test version of Stripe because we don't actually have items to ship and we don't actually want to process real payments because this is just a portfolio project. But the matter of switching it is simply a change in the actual Stripe website. You're going to actually learn what it is to actually build using the Stripe API. And beyond that, we're also going to integrate with Firebase to handle our authentication and our storage. So with Firebase, we're actually going to be able to authorize our users using Google so that we can sign in with our Google accounts. And once we sign in, we're also going to provide a sign out feature and a sign up and sign in with email and password feature. So it's going to be a really fleshed out, fully complete e-commerce platform, just like you would build for a real e-commerce company. Now, before we begin, there are a couple concepts that I want us to go over with React so we have a better understanding of what it is that React is actually doing for us. So in order to begin, we're going to have to go to our original Monsters Rolodex application. And now we're going to look at our actual developer tools and we're going to look at our DOM. So we know that our DOM is our representation of our actual application. Inside of our app component that we built, we have that H1, we have that input, and we have this card list. These are all elements that are children of this app. And inside of our card list is those children, these card containers, right? If we were to actually look at this from a very basic representation, we'll see that it actually looks like this tree, right? This was our app. That was that H1 title. This was that search box. This is the card list, and that card list has children, which are these card component nodes. So this tree actually represents our actual DOM. However, in order for our actual DOM to update any of these elements, it's actually extremely slow. So it takes the DOM a lot of energy to update any of these elements. Now, what React does is it copies this actual DOM tree and it makes it in JavaScript, just like we see when we write our JSX. Our JSX also is just JavaScript that returns what looks like these HTML elements. So what React will do is it'll completely copy this actual DOM, except this it will call the virtual DOM. And the virtual DOM is, as I mentioned, just a complete copy of this actual DOM, but in JavaScript. Now, in our application, whenever we update any of the data that ends up being rendered in our components, let's say our fifth monster's email or its display name changes. Well, React doesn't actually want to re-render the entire DOM. It only wants to affect the thing that matters, which is this node. So what we're going to see happen is React actually copies this virtual DOM again, except this time it's going to apply the changes to the data that got updated. So the monster number 5, it's going to change that, the name, it's going to change the email according to however we actually changed it. And then it's going to apply those changes to this virtual DOM and see what that element that got affected would be. So it would end up actually being this element. So it'll actually make the change here. And then what it will do is it will compare this new virtual DOM to the old DOM. And then it will see that this is actually different now, right? This and this are different. So then it will know, okay, let's actually apply the DOM changes to this element. And when it does that, it's actually way more performant because it doesn't have to mess around with the DOM unless it knows exactly what elements it needs to update. And that's why React is so fast, because of its ability to build out these virtual DOMs and then compare and contrast against the real DOM to see what's changed and then make the appropriate updates to exactly the right nodes. Now, can we actually see this in action? Well, we definitely can. What we got to do first is we got to go back to our monsters application. And we're going to make a couple of minor changes first. So in order to see this in action, we're actually going to add a new field to our state, our data, and we're going to call it our title. And what we're going to do is whenever that user search happens, we're actually going to also have it so that our title updates with whatever it is that our user typed in. So instead of filtering out our monsters, what we're going to do is we're just going to display the monsters, right? We don't want that search feature for now. We're also going to add in this title field that we just added to our state. And instead of monsters Rolodex, I want to show the title. So what happens now is that whenever we type, we'll see this title, right? We'll see our title update. Now, if we enable inside of our additional rules, let's just add actually our rendering. What we'll see if we enable paint is that this website will flash green in all the areas that are getting updated. Whatever DOM elements are updating, it will change it. So if we refresh, we'll see the whole page flash green because it's mounting and rendering everything for the first time. Now, let's say we actually start typing in this. Well, when we type this, we'll see that only this title is getting updated. Nothing else is getting re-rendered because React knows that the only thing that needs to update is this title. This title node is the only component in our DOM that needs to be re-rendered. It doesn't touch anything else. And that's what is so great about React's virtual DOM and its efficiency when it comes to deciding what in our DOM to re-render. Now, let's go back to our application and let's undo this, right? So we get our app back to the state that it was before. So let's undo that. Let's remove this title field. Now, we know that we have our monsters array on the state of our app, and we pass that after we've modified it, right? After we create a new array, but based off of this data array, using our search field to filter out the monsters that don't match, and we pass that into the card list. And then our card list component is the one that will then map out using the data that got passed into it, the new cards, right? So if we were to look at this thing again, except let's just focus on our application, right? That monsters array sits at our app. It gets passed in the card list, and then it generates these components, right? And these end up being all of our actual components that we view. This is actually all of our views. What React does when it's actually rendering out the application is that React is based off of this data that we saw, right? The data from the state of our app component, the monsters array, gets passed to this card list component, which then renders out these components, these card components. If, for example, whenever we type in our search field and we update and change that filtered monsters array, right, that gets passed into our card list, then React actually re-renders this entire tree because it knows that the data at this point has changed. So if it's passing that data down to its children, the children are what is going to need to be re-rendered. However, if we can imagine that we moved the data of our monsters and our filtered monsters, all of this into the actual card list component instead. So if we took all this and we moved it into here so that the data actually sits at the card list level, well, what happens if we were to do that same thing? If we were to modify that array at this level, right? Instead of it sitting here, it's now here. And then we modify that array. Well, these children would still get re-rendered, right? React would re-render any part of the tree below this node because the data that's used to generate these views actually sits here. But anything above it, the parent, our app, and then the siblings, right? The search box and the title would not re-render. React has no reason to re-render anything above this node because the data only affects the children below this node. This concept is called unidirectional data flow. So in React, that idea of building views from data is actually very key as to why React's so predictable. So here is actually a quick image of what that looks like. That data is in our state, right? Our monsters array, our search field, all these things. React uses that data to build out the views as we saw in our card list example, right? Where we mapped over that monsters data to build out these card components. And then if the user does anything or the application does something from the viewpoint, right? It'll trigger these actions that update the state. Now, this action, we can see it as something like when we type in that search field. When we type in that search field, that action is trying to update the state, right? The data that we have. It updates the search field, and then that search field updates that filtered monsters array, and then that again gets passed and used to generate the views. Now, that data always flows in this direction. It always goes from the state of our data to building out the views. And then from the views, there might be interactions that make actions that'll update the data again. This idea of unidirectional data flow is what makes React code so predictable and less prone to errors. Because of this flow of data that always goes in this one direction, we can anticipate if something doesn't match, if our views don't match, we know that there's got to be only one place that's causing these issues to come from. That's why unidirectional data flow in React is so awesome. Now, I know this might still be confusing because it's so conceptual, but I just want you to keep this in mind before we start building out our applications. It'll all make sense, I promise. Now, let's get started on actually building out our e-commerce platform.